All right, guys. Are there any questions over the assignment from yesterday? Or did we like the assignment from yesterday for the most part? Wasn't too bad. What we're looking at today is, again, kind of dealing more with these exponential functions. And what we're going to be focused on this time is the natural base e. The natural base e. Now, we can approximate e's value by 1 plus 1 over x to the x. And again, we say approximate because e, just like with pi, is an irrational number. E is an irrational number. So we can approximate it with this 1 plus 1 over x to the x, which is approximately this here, but we can't actually get to the actual value for e. Now, e is going to come up again when we start talking about natural logs and logarithms. And we write the natural, so logarithm we write log, and then this here was going to come up when we talking about natural logs. Natural logs, natural logarithms. And how do you think we'll abbreviate natural log? NL? No, it's LN. No idea why. We call natural logs LN, but we'll get into dealing with these later in the chapter. We won't talk about those or work with them here. Now, the first thing we're looking at is simplifying these e's, because e we can treat as a variable and do a lot of stuff with it the same way we can do with variables. So if we talk about e to the third times e to the sixth, when we have like bases, we add the exponents. So 6 plus 3 is 9. So e to the third times e to the sixth is e to the ninth. And for these here, we're not looking for the decimal value, we're just simplifying them. We can also divide. Well, we can do 16 divided by 4, and 16 divided by 4 is 4. And whenever we divide like bases, we subtract the exponent. So 5 minus 4 is 1. Or we can just say 4e. When we type e into the calculator, for e to the first, we'll actually need to type it in as e to the first. The calculator needs an exponent, even if it's 1. Questions on these so far? Powers of powers. So here we're going to apply the second power to both of these here, which means we'll have 3 squared times e to the negative 4x times 2. Because whenever we have powers of powers, they multiply. Now 3 squared is going to be 9, bless you. Now our negative 4x times 2 is going to be negative 8x. Now we can't leave a negative in an exponent, so we have to move it from the numerator to denominator, or denominator to the numerator. So we're just moving it to the bottom of the fraction. That's it. Questions on this here? So if we take e to the 4th times e to the 7th, we get e to the what? 11th. Because when we multiply like bases, we add the exponent. So 7 plus 4 is 11. Well, it would be nice if 24 divides by 8 evenly. And it does, it's 3. And then we'd have e to the third, because 8 minus 5 is 3. And the last one, so we're going to apply the third power to both e and 10. which would give us 10 to the third times e to the negative 3x times 3. Yeah, apparently. All right, I'll put it on later. Now, looking at this here, 10 to the third would be 1,000. And again, powers of powers multiply, so negative 3x times 3 would be negative 9x. And again, we can't leave a variable with a negative exponent or anything with a negative exponent, so we have to move it from the numerator to the denominator. Any questions on any of these here? We didn't do one with a radical, but let's go on and add one. So let's say the cubed root of e to the 15x. I mean, we could have numbers in it, and taking the cubed root of a number is not too bad. But the main part is doing this here. Now, one way we can look at this is going back to our last chapter. The nth root of a to the x is the same as a to the x over n. So if we rewrote this, we would have e to the 15x over 3. Well, 15 divide by 3 evenly. And it is. And we would have and we get this here. And that's it. Now, we don't have to worry about the x and the cubed root of it because, well, anything we multiply or plug in x for is still going to be a multiple of, well, apparently I'm going to keep erasing, 15. So it's still going to be divisible by 3 no matter what it is because it's still a multiple of 15. Any questions on this here? We're still good with this so far? Exponential functions with this here. Now, the basic form that we have is y equals a times e to the rx. Now, for all the ones we're going to look at, the value of a is going to be positive. And the two main cases that we're going to have is y equals e to the x and y equals e to the negative x. Now, we know for certain that e is definitely greater than 1. As we already showed, e is 2 point, that nasty long decimal. So, y equals e to the x is going to be our exponential growth, because just like yesterday, whenever the base is greater than 1, it's going to be an exponential growth. But however, we can't make e, I can't just change its value, because it's a constant term. I can't just rewrite and decide that now e is 1/2. But if the exponent is negative, it's going to be exponential decay. Whenever that exponent is negative is when it's going to be exponential decay. Now, the reason this works this way is because y equals, if we said y equals e to the negative x. Well, whenever an exponent's negative, we move it from the numerator to the denominator. So really here we're saying y is equal to 1 over e to the x. Or another way we can say is 1 over e to the x. Now, 1 over e is less than 1 because it's in the denominator of the fraction. So we're saying we have 1 over 2 point that long decimal. This is why this here would be an exponential decay function. Because really we're looking at 1 over e to whatever that power is. Questions on this here? So y equals 3e to the x. Would this be growth or decay? This would be growth because our exponent is what? Positive. Whenever the exponent's positive, it's going to be growth. When we're looking at e to an exponent. So here, e to the negative 0.5x would be decay because the exponent is negative. That's it. Questions on this here? So if we looked at 1/2 e to the x, this would be growth or decay? Growth because the exponent is positive. But if we looked at the graph and we put second e to the x and we hit graph, we see this is an exponential growth like we had yesterday. It's increasing faster and faster as we go from left to right. Now the previous one we had, e to the negative 0.5, that mode. X, and we hit graph, we see that we do have that decay function. So it's more based off, is the exponent with e positive or negative? So like the next one here, since the exponent's negative, this would be a decay function. And how about number 6? This would be growth because the exponent is positive. Questions on this here? Now we can talk about compound interest or continuously compounded interest dealing with these e. And it's a way to find interest, but we're not going to focus on that there. That's it. So the homework is on page 311, 4 through 10, even, and 15 through 20.